Good day to everyone. This is a MOOC online course. We are going to discuss about cartographic techniques. In the cartographic techniques, we are discuss about georeferencing and projections. So, what is a georeferencing? Georeferencing means we have the Toposheet 1:50,000 scale and by produced by the Survey of India and other scanned images is there. So, that image we have to convert it into the digital forms. So, in the digital forms we converted into the traditional Toposheet into georeference. So, we need to do some procedure. So, that procedure we called that georeferencing. So, here matches a scanned map, either first we have the Toposheet, that Toposheet we have to scan it, then scanned image, then we have to give the input to the GIS software. That software we do some procedure, then it makes into the we apply into the real world. So, that is that georeferencing. So, here you see that 1:50,000 Toposheet, this is produced by the Survey of India. This is scale is a 1:50,000, 1 centimeter on the map, it is equal to 50,000 centimeter on the ground surface. So, this is the traditional Toposheet. It is produced nearly in 1970 that period. So, everything is measured manually, drawn and produced that this Toposheet. Now, we have to this Toposheet do the georeference. Once do the georeference, we have to make a digitize and like we want to measure the what is the length of the road, what is the boundary of water body, what are the urban is there, settlement is there. These all are the thing we have to measure. What is the distance between one point to other point? These all are the calculation we can perform through the GIS software. So, therefore, we want to do that this Toposheet we have to convert it and do the first step is the georeferencing. So, georeferencing is a very essential to transfer our scanned Toposheet image into digital forms. So, this two picture you see there is one left hand side is a Toposheet, then right hand side our globe. So, easily you can understand that Toposheet we want to represent on the real world, where it is exactly going to fix. Saw that picture, you are seeing the picture of the Buddha. So, different angle is a tilted, the tilted exactly where we fix, that fix we generally understand that is a georeference. So, likewise the basic Toposheet we want to fix exactly where on the real world. One Toposheet is there means the Toposheet exactly where on that real world, where we have to fix that. So, that is the georeference. So, therefore, we want to know that projections and datums and different scales. So, these all are the information we have to know that. So, nowadays that satellite image, aerial images, everything is there, that is already georeferenced and geometrically corrected. Once we give inputted in the software, it is automatically fixed to the real world, but in the scanned map and Toposheet it not georeferenced, that is manually draw and measured everything. So, now we have to convert that to the digital form, therefore, we want to do the georeference. So, coordinate system and projection. So, these are the terminology we have to know when we do the georeference. Coordinate system, projected coordinate system and geographical coordinate system, that is a two coordinate system is there. Geographical coordinate system, you fix the Toposheet in 3D forms, that is that geographical coordinate system, whereas a projected coordinate system, in that we fix that our Toposheet in plane topography, that is a projected coordinate system. That projected coordinate system or geographical coordinate system, there is a latitude and longitude is there, that is a theorem, that the mathematical calculation where we have to go, that is what is that x and what is the y, what is the latitude and longitude. So, these all are the information very important to do that georeference. Coordinate system is a nothing, there is a latitude and longitude, generally we say that x and y, that is that coordinate system. So, in the georeference we are the entire maps are globally there is some mathematical calculation is there, which is the latitude and longitude x and y. projection is a nothing. Our shape of the earth is a geoid shape, is a equatorial area, this is a bulk, there is a undulated surface. Generally cartographer and geographer they called that is a geoid shapes. So, that geoid shape we converted into that plane surface, that is called that projection. 3-dimensional earth into converted into the 2-dimensional plane surface, that is called that projections. So, when we do the projections, our undulated surface we have to represent exactly. So, that is a little bit difficult task. So, sometime when we do the projection, so we are miscalculate some shapes, some area and distance and direction, that maybe is something tilted, something miscalculated, there it is happen. So, therefore, so exact projection is not there. So, almost we are entire world we are using that WGS, World Geodetic System, and Mercator projection we are using. So, cylindrical Mercator projection, in the polar area they are using that conical projection. So, different projection all over world is using. So, now we understand what is the projection means. 3-dimensional earth converted into the 2-dimensional plane surface, that is called that projections. So, this picture you can understand clearly, that is our shape of the earth. Now, you converted into the plane surface. So, 3-dimensional into the 2-dimensional, that is called that projections. Datum simply say that reference point. So, reference point means in the entire world, so one reference point is there. Similarly, different region have their own datum. For WGS 1984 we are apply for the entire world, but NAD North American datum they are measured their own country and they have the fixed that is a fixed datum for their own country. Similarly, different region, different country they have the own datum, but globally we are apply WGS, World Geodetic System 1984 that system. So, generally global datum and regional or local datum, 2 datum globally we are using nowadays. So, this picture you can understand clearly. So, that blue color represent that shape of the earth, that red color is that datum, that blue color is the geoid mean sea level, then local datum. So, fit for the local area, the red color is the global datum. So, datum is a nothing, it is a reference point to measure that area. So, actually our earth is a geoid shapes. So, local datum only measure that particular country, we have to produce the map or we have to measure that exact location x and y where you stand, that things they are using that local datum. Global datum mostly entire world apply, that is a general system. For example, WGS 1984 is the World Geodetic System, entire world may apply. Some country they are measure their own land and they are using the local datum. Best example is the NAD North American datums. One more thing we have to understand that UTM grid zone. So, UTM universal transverse Mercator projection, that grid zone is the 41 to 46 and 47 it is come to the India. So, you see that the red symbol, you see the 41, 42, 43, 44, 45 and 46 and 7 it is come under that Indian things. So, you see here India it is come to that Gujarat, this further is a 42, then 43, 44, 45, 46 and 47. If you take a Tamil Nadu, the 44 UTM 44 is the good for, that is a fixed for the correct locations. So, now we move to that how to do the georeference in the open source GIS software. So, look at that, this already you will know about that QGIS, this is the open source software. If you need any tools, you go to that plugin, you add that if you need the georeference tool it is available here, and you want to that map, that is also here available. Some tools already we installed, that OSM standard. Look at here, there is that base map is there. So, it is we are using this map as a base map for our reference. So, now we are going to add our topo sheets. So, The topo sheet produced by Survey of India. Here you go to the layer, in the layer you go to the add layer, in the add layer add raster layer. You know that what is the raster layer and vector layer. Our topo sheet and satellite image come under the raster image. So, add raster layer, there I have to navigate where my topo sheet is there. So, here in the desktop I have that folder Indian Survey of India topo sheet 57 n by 8. So, I added now, then add, then close it. There is a zoom to layer, here you see there, here the latitude longitude it is not visible, it is now like a topo sheet, but it is not georeferenced. You see there latitude and longitude, it is moving wherever you go, it is moving, that is not exactly right latitude and longitudes. When you apply into the real world, you see there it is move somewhere in that South Africa. Do the georeference, first you go to that layer, the tool is there georeference. If you not there, that is tool, you go to the plugin and install the tool. Here already we installed that, therefore, I close it. You are searching here georeference like that, it will come, you can add it, it is simple way. We already installed there, you go to the layer and georeferencer. Here is a georeferencer. Now, again I want to add this topo sheet into here. Added that topo sheet. So, here I want to setting that some basic transformation. Now, I click here, you see the transformation types, there is a linear and helmet, polynomial, polynomial 2, polynomial 3, generally we give the linear, but there is a topo sheet, we need minimum 3 point or 4 point, that is why polynomial with that point means GCP ground control point. So, 4 point we have to fix on the topo sheet, we have to mention where that point fixed exactly latitude and longitude, minimum 3 or 4 is a necessary to fix that exactly the topo sheet where on the real world. Therefore, we give that polynomial 1. Then here this is the projection and the coordinate system, we have to set that. Go to here, I already told that EPSG, which means European Petroleum Survey Group, 4326 means their number, WGS 84 means World Geodetic System 84. Then I click that OK, I selected that, then output file where I am going to save. Here I will put it that same topo sheet number georeference, then save it. Then resampling method, traditionally we are giving nearest neighbor, bilinear and cubic, but most acceptable is nowadays is a bilinear and cubic. So, I will give here bilinear, then I will give finally OK. Then next you take that this tool add GCP point, that is that GCP point means ground control point. You first you select the 4 corner, this either you go to the right to left or left to right, that is your own wish. So, here I fix that latitudes and longitudes is there in the topo sheet. Here our latitude is a 14 degree 15 minutes, our longitude is that 79 degree 15 minutes, but here this is the degree minute second DMS, we have to convert that decimal degree. So, therefore, we need to do some calculation. Look at here this picture. Generally 60 minutes we give the 0 here and 15 here and 30 here and 45 here. But DMS to degree minute second to decimal degree we have to convert it. This 15 going to 25, 30 going to 50, 45 going to 75 and 0 it is a 100, like that it changes. So, where it changes, our topo sheet is a degree minutes second DMS. In that doing that georeference in the open source GIS software, we have to convert that degree minutes second into decimal degree. Look at our topo sheet. X is our longitudes, y is our latitudes. 79 point, here is a 15, I give the 25, 79.25, here north is 14.25, first point I created, then OK. So, it came here. Then you take this tool, pan tool, you move another corner here, again you go to that add GCP ground control point. If you zoom and fix that point, here my x is 79.30 means here 50, 14.15 means 25, then OK, then 2 point is added. Now, I am going to add my third point here. If you wrongly placed latitude instead of longitude that places, your map may be is tilted. So, that is why you have to exactly type where you want to fix that your latitude and longitude, where you have to type that is a very important. If you change anything latitude typed area, you typed in longitude means your map is tilted, it is wrongly projected. Therefore, be careful when we do the georeference. So, just so you remember, always our India is a longitude is that highest value than our latitudes. So, just you remember this when we do the georeference. If you make anything error, there is a tool is there, delete the GCP point, that is also here possible. So, do not fear about that, you do the right or wrong that things. So, next is that my third point I am going to add here 79 degree 30 minutes mean 50, then 14 degree 0 means I put it that 0 same things, then I will give OK. Then go to the my final fourth point here. So, I take my ground control point, final point here, I zoom it exactly the central place, you have to mark it 79 degree 15 means 25, 14 degree 0 0. So, my 4 corner I fixed on the topo sheet to apply the topo sheet where it belongs to the real world. Then I give it OK. Then you take this tool, that is the start georeferencing. Then our georeference is finished. There is a residual error is there. You look at here, this residual here towards 0 means you are georeferenced very accurately. going to 2, 3 means you are maybe something you have to mismatched, wrongly placed. Okay. So, be careful when do the georeference. Then I close it. It is asked, do you want to save your GCP point? Yes. Further use, maybe I saved it. So, as it is, I will give it GCP point, then save it. This is my topo sheet, georeferenced topo sheet, it is in the layer. Now, I zoom to layer this, I remove this layer, this is our real world. So, exactly look at this line, this is our real world, this is our topo sheet, you see this line, it exactly fits into the real world. So, this is the georeference, even you see this line, you see that line in the topo sheet, it exactly the topo sheet fits into the real world. So, this is the georeferenced topo sheet, we learned how to do the georeference. This is the basic and very important. Once you done the georeference, you can do the further analysis, how to distance between that one point and the other point, you create the shapefile. Shapefile is the very important source for that other processes. So, you do that measure that area, distance between the one point to other point, what is the road length, this everything is a possible. Then you can do the further analysis also, here is a possible. So, best for therefore, georeference is the very essential and first for most important steps. So, next class we will see how to do that analysis and create that shapefile, these are the things. Thank you.